the planet-wide winter of Mars. Mars Saga. Mars is often called the red planet because of its dusty surface and rusty color. From space, it appears calm and almost unchanging. Huge volcanoes rise above endless plains, ancient river valleys cut through the landscape, and giant impact craters cover much of the surface. At first glance, Mars seems like a world where every day is the same. In reality, Mars experiences seasons just as Earth does. It has spring, summer, autumn, and winter. But because a year on Mars lasts 687 Earth days, each season is almost twice as long as a season on Earth. This means that winter on Mars is not a short period of cold weather. It is a long and powerful season that transforms large parts of the planet for months at a time. When people imagine winter, they often think of snow-covered forests, frozen lakes, and falling snowflakes. Mars has none of these familiar sights. Its winter is completely different, shaped by a thin atmosphere, extreme cold, and frozen carbon dioxide. The atmosphere of Mars is made mostly of carbon dioxide. During the coldest months of winter, temperatures near the poles become so low that this gas freezes directly out of the atmosphere. Instead of forming frost made from water, Mars forms frost made from carbon dioxide, also known as dry ice. This is something that cannot naturally happen on Earth. As winter spreads across the polar regions, enormous amounts of carbon dioxide freeze onto the surface. A bright white layer begins covering the landscape. From orbit, the polar caps grow larger and larger until they extend across huge areas of the planet. Scientists estimate that during winter, nearly 1/3 of the entire Martian atmosphere temporarily freezes onto the ground. This is one of the most extraordinary weather cycles anywhere in the solar system. As part of the atmosphere freezes, the air pressure across the entire planet changes. Winds become stronger in some regions, while weather patterns shift in others. Even places thousands of kilometers away from the poles are affected. When spring finally arrives, sunlight returns to the frozen landscape. The dry ice does not melt into liquid. Instead, it changes directly from a solid into a gas through a process called sublimation. As this happens, the atmosphere slowly becomes thicker again, restoring the carbon dioxide that disappeared during winter. This yearly cycle repeats over and over, changing the planet with every passing season. The frozen carbon dioxide also creates unusual landforms. In some places, sunlight passes through translucent layers of dry ice and warms the ground beneath. The trapped gas builds pressure until it suddenly escapes through small openings. When this happens, dark dust is blasted upward like a natural jet, leaving beautiful fan-shaped patterns across the ice. Orbiting spacecraft have photographed thousands of these patterns every Martian spring. From above, they look almost like giant flowers spreading across the frozen surface. These features exist nowhere else in the solar system. Winter also changes the appearance of the sky. The already thin atmosphere becomes even colder. Dust activity decreases in some areas while frost covers rocks and soil. The landscape becomes brighter as sunlight reflects from fresh ice deposits. In other regions, powerful winds continue moving fine dust across the frozen ground. Although Mars receives less sunlight than Earth, weather remains surprisingly active. One reason is the enormous difference between daytime and nighttime temperatures. Even during winter, sunlight can warm certain surfaces during the day. After sunset, temperatures drop rapidly. These constant temperature changes keep the atmosphere moving. Scientists monitor winter closely because it affects almost every part of the Martian climate. The freezing and evaporation of carbon dioxide influence atmospheric pressure, wind circulation, cloud formation, and even the movement of dust storms. Without winter, Mars would be a completely different planet. Clouds also appear during the colder months. Unlike Earth's thick water clouds, many Martian clouds are made from tiny crystals of water ice or carbon dioxide ice. These clouds often form high in the atmosphere and drift slowly across the sky. Some are so thin that sunlight passes through them almost unchanged. Others create delicate streaks stretching across the horizon. Future astronauts may witness these rare clouds while living on Mars. Another fascinating feature of Martian winter is the formation of frost far away from the poles. During extremely cold nights, thin layers of frost can develop on rocks and dusty ground. As morning sunlight reaches the surface, the frost quickly disappears back into the atmosphere. Although these frosts are usually very thin, they demonstrate that water and carbon dioxide continue moving through the Martian environment. Winter also creates challenges for robotic exploration. Solar-powered spacecraft receive less sunlight, reducing the amount of electricity they can generate. Engineers carefully plan missions to ensure enough energy remains available during the coldest periods. Extremely low temperatures can also affect batteries, electronic equipment, and mechanical systems. Fortunately, modern spacecraft are designed to survive these harsh conditions. Some use radioactive power sources that continue producing electricity regardless of sunlight. These systems allow exploration to continue throughout the Martian year. Scientists are especially interested in how winter affects underground ice. Changes in surface temperature may influence the movement of water vapor beneath the soil. Studying these processes helps researchers understand how hidden ice deposits evolve over time. This information is valuable for future human missions because underground ice could become an important source of drinking water and oxygen. Winter may also help preserve ancient materials beneath the surface. Cold temperatures slow many natural processes, allowing geological records to survive for incredibly long periods. Rocks buried beneath frozen ground may contain clues about ancient climates that existed billions of years ago. As exploration continues, every winter provides another opportunity to observe Mars changing before our eyes. Orbiters compare images taken over many years, revealing how ice expands, retreats, and reshapes the landscape. Each season adds another chapter to the story of the Red Planet. Although Mars appears lifeless, it is not inactive. Its weather, climate, and seasonal cycles continue operating just as they have for millions of years. The frozen poles grow and shrink, clouds drift across the sky, frost appears before sunrise and disappears after daylight. The atmosphere itself freezes and returns every single year. This endless cycle reminds us that Mars is still a living world in a geological sense. Its landscapes continue evolving, even if the changes happen slowly. The planet-wide winter of Mars is unlike anything found on Earth. It transforms the atmosphere, reshapes the polar regions, and creates natural phenomena seen nowhere else in the solar system. Hidden beneath the frozen surface are clues about the planet's past, its present climate, and perhaps even its future. As scientists continue exploring this remarkable world, every Martian winter brings new discoveries and new mysteries waiting to be understood. Thanks for watching.